So how do you see that this given solution is infeasible? The decision value of the decision variable from f1 to a is 30. Now we see that customer A requires only 20 cases, though because we deliver too many cases to customer A, this given solution needs to be infeasible. There are other reasons. For example, you see f1a, f1c. When you add up these values, it's 50. That means out of factory f1 there's an outflow of 50 cases, but we only have 40 cases. This is another reason why the model is infeasible. For a question like this, it would be sufficient if you provide me one reason why the solution is infeasible. Now you need to change some of the decision variables to come up with a feasible solution. And then you multiply the values of your changed solution with the cost values in order to calculate the total cost of this solution. So as an example, if we stick to the given solution, we would have to calculate 30 times 250 plus 20 times 380 plus 60 times 990. And the outcome of this calculation would be the value of the objective function. How can you decide if this is a minimum cost solution? In this small example, I did not introduce you to any algorithm for an optimal solution. However, if you find an assignment of different transportation relations of different transport quantities to this model that results in a lower cost solution, then you showed that the given solution is not a minimum cost solution. Okay, now let's have a look at a method on how to solve these types of transportation problems. Modeling is the first step of solving the problem. Applying an algorithm is the second step. Here, the transportation problem can be solved via Microsoft Excel, for example. But this we need the Excel solver. Usually the Excel solver is not installed by default, so you might have to install it first before you can follow this example. The algorithm that we want to apply is called the simplex algorithm. You will learn more about the simplex algorithm in the course Operations Research, which you will have next semester. Once you know the simplex algorithm, you can solve the transportation problem via hand calculation. Today we do not go into details of the simplex algorithm. However, we try to use Excel, which has an implementation of the simplex algorithm, to solve our problem. If you open your Excel and you go to the Data tab, you should see here the solver symbol. If you do not see the symbol, then it means that you need to load the solver add-in first. As I said, by default this might not be installed, so you need to install it first. There are some YouTube videos that show you how to install it, and I will try to provide a link for you. On Moodle I uploaded the Excel file which provides the structure of the transportation problem. In general, the cells with blue background, they represent data that is given. Row number 5, the gray cells with orange font color, these are the values of our decision variables, and they will be calculated by the solver. This is the row for our decision variables, and this is a row that represents values for our constraint, which is also implicitly calculated by the solver. Then we have this green cell, green background cell. This is the value of our objective function. So let's switch to the Excel sheet. This is now the Excel sheet, and I modeled the transportation problem for the fish transportation according to our slides. So here I have our decision variables. Here in this row with the gray background and the orange font color, I modeled the values of the decision variables. As you can see, right now the values are all 0. In row number 7 with the blue background, I entered given data. This is the given cost data. This is a cost matrix for transporting fish cases between different locations. So column B represents the decision of transportation from factory 1 to customer A. And when you look up in our cost matrix in the slides, this is 250 base for one case. In column I, we have the decision variable that decides about the number of cases that go from factory 2 to our customer D. And the cost for transporting one case is roughly 1.5 reals. This is how to read this cost matrix. Now, how do I calculate the objective function value? The objective function value is here in this green, in this cell with the green background. You see, I used the Excel function SumProduct, which basically is doing the following. We calculate this vector, we multiply this vector with the objective function coefficient vector. That is, we multiply the value of this decision variable with these transportation costs plus this value times this value plus this value times this value plus this value times this value, and so on and so on. And this is our objective function. Okay. Now let's have a look at how this matrix with a site constraint has been designed. So recall our mathematical model. I exactly modeled everything that is on this slide in Excel. Though the first equation, the first site constraint, is represented by the first row of site constraints in Excel. So this site constraint is modeled in this first row. You see everything that is transported out of factory F1, everything that is transported out of factory F2, 121 cases, and everything that's transported out of factory F3, 95 cases. How do I set the ones here? Let's go back to the model. Though we have 1 times the decision variable x f1a, x plus 1 time decision variable x f1b plus 1 times x f1c plus 1 time x f1d plus 0 all the other decision variables. Yeah. So for each decision variable that goes into this equations, we have the coefficient 1. The same is applicable for constraint number 2, where we have the decision variable f2a, f2b, f2c, f2d, which is the second row, which equals to 121. This is here. The last 4 rows of this matrix represent the constraint that ensure that each customer warehouse is provided with exactly its demand. Though now here we have everything that is transported into warehouse, or here we have the coefficient for the decision variable that decides what is transported into warehouse A from factory 1. Here we have the decision variable that decides what's going into warehouse A from factory 2. And here we have the case what is transported from factory number 3 into A. And the total demand of customer A is 81 units, 81 cases. And the same is true for all the other 3 customers. Again, here in this cell with the gray background, I have the same formula like in our objective function. We multiply this row with the values of this row. Yeah. This is how it works. Of course, there's no entry in many cells, so this is handled as a 0 and not taken into account. So now the decision variables are all set to 0. Of course, we do not have a feasible solution, but the total cost of this solution is of course 0 as well, because we just multiply 0 with our coefficients of the objective function. So now let's solve this model via Excel Solver. I click on the Data tab, go to Solver. First of all, I have to set the objective function. This is here our green. It is already pre-selected because I did it before. Then I need to decide if I want to minimize or maximize. Here we want to minimize because we are interested in the minimum transportation costs. We need to tell the solver which are our decision variables. These are our decision variables. These are the cells the solver is allowed to vary. And we have to define our site constraints. Here our site constraints are defined in the following sense. Every cell, every value with a gray background in this column has to be equal to every value on the given value which specified our supply and demand of the customers. So we have to click this checkbox to ensure that we only deal with positive values or non-negative values for our x values. We have to select the simplex algorithm. This is a method you will learn next semester. And now we can let Excel do the work by clicking on solving. Here I select keep solver solution. OK. And now you see that the solver filled these cells with values. That means from factor F1 we transport 45 cases to D, 43 cases from F2 to